Good morning. Welcome to Deep Dive, Take a Tour with Geospatial. Before we get started, just wanted to go over a few housekeeping notes. We are encouraging everyone to go beyond, to interact with us beyond the session rooms. Feel free to tweet us. Our handle is @MarkLogic and the hashtag is MLW16. Recordings and PDFs of these slides will be available in June at mlwonline.com. We do encourage you to fill out these surveys. That helps us create content that is relevant and timely. You can turn them in back here with Wilson, who is scanning her badges, or back here. My name is Caroline. And without further ado, I'd like to introduce Jennifer Tsao, Product Manager, MarkLogic, and Jake Fowler, PhD, Senior Engineer, also at MarkLogic.
Great. All right, thank you very much, Caroline. Again, my name is Jennifer Tsao. I'm a product manager at MarkLogic. I focus on our geospatial features. Very excited that you're here joining us today, and I'll be here sharing a little bit about why MarkLogic allows you to interact with location in a different way, and then Jake is going to go into the details and talk about the magic about how this all works. So, Jake, if you want to briefly introduce yourself.
Yeah. I'm Jake Fowler, Senior Software Engineer at MarkLogic, and currently Lead Engineer for the Geospatial features.
Great, thank you. All right. Before we get started, I want to do a quick poll to kind of understand who we have here in the room today. First off, I'd like to get an understanding of how many of you are current customers of MarkLogic or have played around with MarkLogic's geospatial capabilities before. Great, we've got a handful in this room. Nice, I'd love to talk to you afterwards and learn more about how you guys are using our capabilities. Okay, how many of you have not used MarkLogic's geospatial capabilities, but you're familiar with the geographic information systems community or geospatial technology in general? Okay, great. Got a handful in this room. And finally, how many of you attended our Designing a Geospatial App with MarkLogic yesterday? Great. Well, I'm glad you decided to come back and listen to us present again and learn more. All right. Location, location, location. If you're part of the real estate industry, you understand that that is one of the most important factors for you as a real estate agent. Well, I would argue this little device is changing how location affects all industries today. Anybody want to guess what I have here on the screen on the left-hand side? Great. We got some experts here. Yes, so this is a GPS sensor. It's a GPS chip with a built-in antenna. It's 4 grams, smaller than a quarter. It can track up to 22 satellites on 66 channels, and it provides up to 10 location updates a second. And all of this for under $30. Really cheap. So in today's global economy, it's not just us and our personal lives being impacted by location, but because of the plethora of location data available to everybody today, companies are understanding that it's necessary for them to implement and integrate this into their operations. You might be thinking, or sitting in this room today saying, I work for a bank, I work for a hospital, I don't really work with location data. Well, researchers have shown that 80% of all data has some type of geospatial component to it. So I would challenge you not to think about geospatial or location data as just maps or geographic analytics, but think about the data that your operations run on an everyday basis and the location components of that. There's spatial aspects to a lot of your data, and I would argue that there's more than that meets the eye. Today, I'm going to kick off and talk a little bit about why MarkLogic provides a unique solution and a paradigm shift for how you can interact with your location in a different way. So if you're familiar with the geospatial industry, this might bring you for a little bit of a loop, but I'm glad that you all probably attended the keynote today and David Gorbett provided a great foundation for a lot of what I'm going to talk about. And then we'll go into the deep dive, and Jake will talk about the magic. So get ready for the paradigm shift ahead. Today's world of geospatial technology, there's a lot of concepts and ideas that have been formed by the technology that was then available to model them. So for example, in the geographic information systems community, there's this concept of a feature. A feature is an entity that can be put on a map. That might be this chair over here, this building, right? Silvano here in the room, he could be a feature that moves around on a map. Well, the way that this concept of a feature has been defined has very much so been influenced by the tools available to model them, so relational technology. And I would argue even that in a lot of ways that we may have constrained the idea of what a feature can be. So let me get concrete with you. Throughout this presentation, I'm going to try to throw in a bunch of examples so you can see exactly what I'm talking about. So this is an example of a table of features where each row is a feature. It represents a building. So here we have a row, a feature, that is a training center, and it's represented by a polygon on a map. And this is that geospatial component of your data, right? If you have a map, you want to plot a training center, you identify it as a polygon, and this is a simplified view of it, but that polygon probably has some latitude and longitude coordinates that comprise of that polygon, and you put it onto a map. Well, I've defined my table of buildings with a geospatial column. They're represented by polygons, and there's a fixed schema associated to that. So a building, I have a feature type column that defines how this building is used, and I also have a feature used. And there's a fixed schema around how you would define a building in this relational mindset. And when you actually look at documentation regarding how you define a feature, it's like you're reading a data modeling document for relational databases. These diagrams here are extracted from a specification published by the Open Geospatial Consortium. The OGC is to the geospatial world as the W3C is to the internet. And these diagrams essentially illustrate how you would define a feature. You've got a feature, you've got a feature schema, you've got a geometry schema, you have an attribute schema. A lot of what we just talked about previously. And quote, if you read that specification, it says that a feature demands rules for representing each type with WKT, where representing each feature type with WKT is explicit. So WKT is, well, it's a way for you to, it's a type of geospatial data format. So an example might be buildings need to be represented by polygons. Also, there's an attribute schema. So we just talked about there's a strict attribute schema for how you would represent a building. So as you go around defining your geospatial features, you're really practicing data modeling in a relational mindset. Well, you're here at MarkLogic World. So today, I'd like to talk about how MarkLogic allows you to think of and interact with location in a different way. Through this presentation, I'm going to bring you through 3 paradigm shifts for you to think about how you can interact with location in a different sense than the model that we've just presented before. First one. With MarkLogic, you can create features that mirror reality. What am I talking about? For example, a feature may vary in geospatial representation depending on how you want to interact with it. It also may vary in attributes depending on how you want to interact with that. Let's go through an example. Say I'm an emergency service provider, and there's a fire going on in my neighborhood at 1651 Union Street, San Francisco, California. There's a set of buildings there. They're on fire. But at that location, what I realized is that this set of facilities is used in a different way throughout the week. During the weekdays, its primary use is a school. Well, during the weekends, it might be used as a training center. And maybe on Sundays, there's a local church that rents it out and uses the auditorium for their services. So all of that information is associated to that one feature. And I, as an emergency service provider, I want to be able to drive up to this location, pull up my app, look at all these details, and understand how I can deploy my field personnel in a smart way, right? It's important for me to know how this set of facilities is used so that, if it's during the weekday, I might have young children in the building. If it's a training center, there's certain buildings where people are taking their training classes. I want to know all of that. So let's go through how you would model this in MarkLogic. And you'll see there's a lot of ideas here that are very similar to what you've heard this morning. And it's great. So repetition is a key to learning. So here's a document that represents that one feature. You've got that address right there. Ooh, a little pointer right here. Let me walk over here. Move a little bit easier. So here you go. You've got this one feature, and you've got an address right there, right? And you've got a point that's associated to that address. It's a location. And embedded within this one feature, you have multiple geometries. So you have a school, right? It's used as a school. There's a geometry related to that school that is associated with those set of buildings. Then you have another element here that indicates that this feature is used as a training center. And you have a geometry that is associated then to those two buildings that we saw previously. And then you have another set of attributes here that talk about that building that is used for a church. Well, how would you do this in a relational model? You would build 3 features associated to each of those use types, and then you might build a relationship saying, well, those 3 features are associated to that one coordinate point. I would argue already here, you're not representing one feature anymore. You've built 3 features, and you've said they relate to this one coordinate point. It's fundamentally different than this document model, where you really only have one feature. Okay, great. Well, maybe you say, well, I've accomplished my purpose. What's the big deal? Well, what happens when you have a variance in attributes? How do you fit that into the schema? You might have a bunch of columns, but they'll be sparse. MarkLogic document model, you don't have that issue, right? You have the name of the elementary school, you have a population. For the training center, you have contact information. For the church, you have a contact phone. You've got some notes that they meet in the school auditorium. It's very easy to fit those different types of elements and values and attributes into this model. And that's useful because, as David mentioned this morning, maybe you are collecting a bunch of different data about all these different types of features, and you may not be using it in your application, but you don't want to lose that data either. Okay, well, what if I introduce another feature that doesn't fit the same schema? So for example, now I've got a building that represents an apartment complex, and I've got a point that represents the location of that apartment complex. But it's not used in multiple different ways, and there's no extra sub-geometries as part of that feature. Well, I can force fit it into my schema, right? I've got a point here. I don't know if you guys can really see this point on the screen. Looks like the laser's a little bit spotty. But you might have a point here, right? But then you say, well, okay, I've got to somehow force fit my schema to make this work. So I'm going to now add my point here and say they're both the same thing. So what's going on here? Now you've got duplicate data, and you're kind of cheating your schema, or you're not really representing how you're not the two ways that you're representing these features is fundamentally different. Okay, so as you can see, MarkLogic provides you greater flexibility in defining a feature. And when you have greater flexibility in defining your feature, then you have greater flexibility in how you build your application. Maybe at first I built my application so that it just provides me directions to this one building. But now I want to be able to change my application so that I can click on that little location and it'll have a pop-up and I'll have different geometries that I can understand and say, hey, this building is used as a training center, this building is used as a school. Or you might have 3 different applications looking at the same piece of data, but showing it to different users in different ways. So the greater flexibility you have for modeling your data and modeling your location data provides you greater flexibility in how your users can interact with that location data in your application. The second paradigm shift is integrating your location data across your organization. Traditionally, geospatial systems have lived in a separate system, and for good purpose too, because there's some very fundamental geospatial use cases which require heavy geospatial analysis. But what happens over time is that, say, for example, I work for a hospital and I have a table representing patient data, and I want to be able to map that. So now I'm talking about using some kind of geographic analysis capabilities to understand my data. What would I do? So typically what you would do in a relational system is you would have a database dedicated to your geospatial data. It would be spatially enabled, this one column, so that these patients, are associated to this address at that point. And great, now I can map it. I've got my patient records, I've got their addresses, I've got those addresses associated to a spatial database that then I can then use to create a map. Well, what if your questions aren't that simple? What if you're a healthcare provider that has grown through mergers and acquisitions? You've got multiple hospitals. You've got the Oakland Clinic, you've got UCSF, you've got the Palo Alto Medical Foundation. And now you want to ask questions such as, tell me all of the different hospitals that my patients are going to, or tell me specifically which patient is going to which hospital. These questions get a little harder because now you're talking about multiple different tables, multiple different databases across different organizations that all have different schemas. You've got patient records that look different, you've got appointment records that look different, and so when you want to ask those questions, it becomes really hard. So again, and maybe we'll go through an example, and we'll go through an example specifically focusing on Sally Smith. And you notice here that Sally Smith, maybe she goes to both the UCSF and the Oakland Clinic, but she's represented in two different ways here because she's gone to these two different hospitals. So let's walk through an example of how do we get a 360 view of Sally Smith. So taking those tables on the previous page, putting them here, you've got a document representing Sally Smith. And this is just an example. The way that you would model your document and model your data would depend on the types of questions you want to ask. And I won't be following the envelope model previously talked about by David this morning. I'm just walking through an example so you can understand the concepts of integrating your location data into one space. So you can think about how you could transform it in different ways and model in different ways depending on how you would want your application to be built. So say I have this patient record that I want to, I have two patient records, one from UCSF, one from Oakland Clinic, put it into one document. So now I've got a patient document capturing those two details together. Great. Well, now I take the appointment records as well and capture it in that one document. Very easy. Well, okay, let me spatially enable it, which, MarkLogic, we don't really talk about spatially enabling because your location data really is just another part of the rest of your data. You just put in your coordinates, you put in your geospatial information right into the document, and you don't really have to treat it in a special way. And that's kind of a nuanced point, but location data living with the rest of your data means that you no longer have to treat your spatial data in a special way. And you're able to contextualize the rest of your information with location rather than having a database that is dedicated to focusing purely on geospatial types of questions and the rest of your data in other areas. So thinking about how you can integrate location across the rest of your organization is really just about taking your data and contextualizing it with location, putting that location information right into the rest of your data. Okay, third paradigm shift is interacting with location using rich, complex queries. MarkLogic has built-in full-text search, allowing you to mix your full-text search queries with location search all together into one. It's a very natural thing to do. And integrating that into your operations. We also have a alerting functionality that you can use. So being able to do full text search with location data and having alerting functionality allows you to ask powerful questions and build powerful features for your operations. Go through some examples. So you have a database full of documents representing patient treatment histories. This is very similar to a previous document. I have a document record for Henry Evans, and this is his patient treatment history. We've got some information above at the top. You know, this address as well as the coordinate point that his address is associated with. And say we now have a section, the bottom section of the document represents his appointment records, all his treatment history information. And this is one specific appointment record. Well, you can easily combine a full text search with a geospatial question, with geospatial components to ask interesting questions. So for example, find me all records for patients who live in the 5-mile radius of Flint, Michigan that mention the phrase abdominal pain and nausea within the same appointment. So what is this? This is a location query with full text search as well as a container query. So MarkLogic has this idea where you can actually specify particular regions of your document that you want to choose to query upon. So this is a very, very powerful idea. Another example, building alerting functionality based on location. Say maybe you have a patient under 10, so you can do a range query based on their date of birth, who lives within a 5-mile radius of Flint, Michigan. When they check in, trigger an alert so that a nurse knows to come and conduct a lead poisoning test. So building that kind of operational functionality based on location. Some very powerful ideas. So when you can build those types of queries, you can ask where questions that you haven't been able to ask before. Because one, now your location is contextualizing the rest of your data, and you're able to create queries that ask questions mixing that data along with your location data to combine and compose them into queries that weren't available for you before. So thinking about asking these types of questions with those tables that you had beforehand across all your different departments. Customers are using MarkLogic's geospatial capabilities to do some pretty neat things today. Fairfax County, David talked a little bit about that earlier this morning. They have a search platform that searches over 5.4 million records. So Fairfax County developed this repository so that land developers and residents could access real-time information about zoning changes, land ordinances, as well as property histories. So now, if you go to the Fairfax website, you can actually access this application. You can type in a query such as hot tub, and you can see a heat map of all the different properties in Fairfax County that own a hot tub. Pretty cool information. Well, the neat thing is that the data that this search platform is searching, there's 530 different permit types. It's coming from 9 different data sources. And every single day, they have new imported data of around 1,500 documents. So it's a lot. There's a lot of information that's coming into this application, and it's giving people real-time access to how property is being used in their area. Another example, DHL Parcel Benelux. They are a shipping and logistics company that are providing tracking and shipment services to consumers on behalf of retailers for over 150,000 packages today. With their previous system, they were missing their service level agreements, and now with MarkLogic, they're able to provide tracking information to consumers on an average of 200 milliseconds. So really fast, speedy, first-class service. And they were able to deploy this application in a matter of under 10 weeks. And they're looking into actually integrating different types of unstructured data, such as weather reports and real-time traffic information, to better estimate delivering shipping times to their consumers. And that's why we talk about our geospatial capabilities as one of our powerful features. We've got a number of specific different types of functions and capabilities associated with MarkLogic's geospatial capabilities. We allow you to work with different types of geospatial data. For those of you who are familiar with the geospatial world, not only do you have JSON and XML, right? But even within XML, you have KML, GML. You have a bunch of different ways to actually represent geospatial data. in the land of data. And so MarkLogic makes it really easy for developers to build location-aware applications because we have built-in functions that allow you to easily work with that information. We have built-in geospatial point search. We also support the WGS84 and the raw coordinate system. And in MarkLogic 9, we're going to be introducing soon geospatial region search as well as double precision indexes. Geospatial is going to talk a little bit more about what else is coming out in MarkLogic 9 during tomorrow's keynote. Oh, here? Oh, these presentation materials are actually going to be provided to you, so you can also download them later on afterwards.
This one asks a question. So it's not relevant to this topic.
Mm-hmm.
So when you say first-class PD service to retail clients, right? So with the data, what is in MarkLogic, how do they able to achieve that PD? Is it something which they put something on top of the data analytics, or what do they do to get the to meet the SLAs?
To meet the SLAs. So it has to do also with how they change their architecture. To get into more detail about it, maybe I can. Yeah, we'll take it offline, and I'll chat with you afterwards about it. Thanks. But great question. Please definitely let us know if you have any more questions afterwards. So I'll hand it off to Jake right now.
Okay.
All right, thank you. All right, so I'm going to talk a little bit about the technical details of how MarkLogic handles your geospatial data. So let's start by looking at an example, some sample geospatial data. So this is a GeoJSON record that I pulled from some San Francisco public data sets. So this represents a feature. So, well, doesn't really work. It represents a feature, has a name, so various properties, and then it has a geospatial component, which is this last bit. So we can also see that there are lots of different formats that you can represent the same feature in different ways. So the first way, GeoJSON, second way, KML. In both cases, the actual geospatial part of it is actually just a very small component. It really consists of just these two numbers, a latitude and longitude. So I'm sure you're all familiar with latitude and longitude. These two numbers represent a point on the Earth. Sometimes we like to unfold the Earth and think of them as representing X and Y coordinates. But it's important to remember when we do this, it doesn't remain accurate because we get all this distortion around the poles when we unfold the Earth. That's going to be an important point later. But let's ingest this document into MarkLogic. So this would be sort of how MarkLogic sees the document. Internally, MarkLogic represents all of its documents as tree-type data structures. So MarkLogic automatically understands the structure of the document. It understands the structure of the document, but it does not automatically understand the meaning. It doesn't automatically know that this represents a geospatial component. So maybe I'll also mention here, just to follow up with Jennifer's comments about a paradigm shift. So GeoJSON is a data format that you can really see it sort of came from the relational world. Really, this is representative of a row, and it's just sort of the geospatial part is kept separately. So MarkLogic is flexible in the way that you handle your geospatial data formats. You don't have to format it in this way, as there are a number of different ways that you can store your geospatial data, including in embedded into your documents, living alongside your other data. So MarkLogic automatically understands the structure, but it doesn't know the meaning. So this is the property of MarkLogic. We say it's schema agnostic. It doesn't care about the meaning or the particulars of how you structured it, unless you tell it. So you have to tell MarkLogic, when you set up your geospatial indexes, you have to tell MarkLogic what part of the document contains the location. And the reason it needs to know this is in order to enable geospatial search, in order to be able to find documents that mention locations in specific places. So what do I mean when I say geospatial search? So geospatial search is the feature of MarkLogic that allows you to answer questions that have some location-based component. All the park benches between 5th and 7th Street been painted, and so forth. So in order to understand geospatial search, you have to understand geospatial indexes. These are the means, the technical means by which MarkLogic enables fast geospatial search. So really, these are two sides of the same coin. So what is an index? I'm sure you're all familiar with indexes, both in the computer sense and also in the pre-computer sense. So of course, in the back of any book, you'll find an index. And these indexes contain sort of three important parts. Some subset of the data, so in this case, some interesting terms. References back to the source, in this example by page number, and some organization so that you can find the items you're interested in this case, alphabetical order. MarkLogic's range indexes work on the exact same principles. So they store some subset of the data, which is what you tell it to by XML document name, or XML element name, JSON property name, or so forth. It refers back to the original document URI. Well, technically the document ID, not the URI, but for the sake of example, I'll use URIs in place of IDs. And the data is of some type that can be sorted, so we can put it in order to find the documents that are relevant to us. So for example, numbers, dates, strings can be sorted by alphabetical order, and so forth. So as an example, if we had data that was in this format, and we wanted to be able to search based on the age of our users, we might create a range index on that age element. Now then what MarkLogic will be doing is it'll be creating two lists. So one list, and again, it consists of these three things, right? We have some subset of the data, the age, references back to the original source, and it's organized, it's sorted. We have two different sortings, one by age and one by the document ID. So what this list, I'm going to focus on the list on the left, what that list allows us to do is to very quickly select ranges of documents. So for example, if we were interested in all users between 18 and 24 years of age, they're all right together in the index, so we can just grab them all very quickly. Now, what does this have to do with geospatial indexes? Well, geospatial indexes are actually a type of range index. The reason why is that points can be sorted. So the way MarkLogic sorts our points, we sort first by latitude and then by longitude. So the end result is sort of a two-dimensional range index. We have two sortings where we sort first by latitude, how far north and south, and then by longitude, how far east and west. So to think about this, here's an analogy that might help. Let's think about how we would implement a geospatial index without a computer. So one way you might approach it would be to use a sort of card catalog. So I'm going to make a card catalog, and each drawer is going to contain the document URIs for documents that reference points on that particular location of the Earth. So a drawer over there would contain all the document or references to all the documents that mention points on Australia, and so forth. So different areas of the world will have different drawers. So then what we can do, so internally, what MarkLogic can do is when you perform a geospatial query, it can very quickly narrow down first the latitude range. Right? Remember, I said range indexes allow you to quickly select ranges. And then you select the longitude range, with the end result being that we limit it down to a box. So we've greatly limited the number of drawers that we have to search. Searching for boxes is enabled very quickly by the index, but unfortunately most interesting regions on the Earth are not boxes. So here, for example, the boundary of the United States is an interesting region. Country boundaries, city boundaries, geographic features, congressional districts are a great source of some very interesting regions. And it could be very important to know, specifically, it makes a big difference if the voter is inside or outside that region. You can't just approximate with a box. So index resolution is easy for rectangles, but other regions require more steps. So let's look back at this United States example. If we wanted to find all the points in our database in the United States, we would probably write a query that looks something like this. So this is creating a query object on the coordinates element, and I've created a polygon that represents the boundary of the USA. And this would find all documents in the database that mention points contained within that region. So how does this work? So when you create this query object, it gets shipped to the D node, which will resolve it from the index. So the first step is to restrict the results based on the bounding boxes. Remember, I said that index resolution was very fast and easy if you're just dealing with boxes. So if these are our data points, then what we can do is we can cover the United States by a bounding box, and that allows us to very quickly eliminate points that are not anywhere close to our region. But unfortunately, we still have some points that we don't want to match. So one solution to that is to use finer bounding boxes. So instead of using just one big bounding box, cover it by a bunch of smaller boxes. So this allows us to rule out even more points. So in this case, there's 2 more that we can eliminate. But again, we still haven't eliminated all of them. And no matter how small you get your boxes, you're still going to, it's not going to be enough. I will note that using more boxes doesn't impact your performance, so we might as well use as many boxes as we can. So if you want to see what the boxes are being used, you can see them with this Geo Bounding Boxes function and pass in the option box % equals 100. That gives you the maximum number of bounding boxes. But as I said, we still have some non-matches. So the next step is that we have to loop through each point and check it and see if it's in the search region or not. So we loop through the points in order. Remember, I said they're sorted. So we go south to north, west to east. And each point has to be checked, and if it doesn't match, we throw it out. So we go through and check all of our points individually to see which ones are the actual matches. So the end result is that the search returns completely accurate results. So no non-matches are left, and no further filtering is necessary. Now this second step here, checking each point against the search region, actually involves quite a lot. And this is because checking if a point is in a polygon on the surface of the Earth requires a lot of complicated geometry. So geometry on the Earth is quite a bit different than the geometry you're used to. So for example, here we have an example of a triangle that has 2 90-degree angles. That kind of thing can happen on a curved surface. It doesn't happen in your traditional flat Euclidean geometry. So this, the fact that the Earth is round makes things a lot harder. So one approach to solving this problem is to use what's called a map projection. So these flatten out your map onto a flat surface. So for example, here we have the Mercator projection, although this is famous because it's useful for navigators, but unfortunately it gives a very distorted view of the Earth just from looking at it, especially around the poles get very much enlarged. So you might try various other projections. There's a ton of these, thousands, all sorts of interesting, colorful names like Eckert and mnemonic and so forth. But ultimately, none of them will work for the entire globe as a whole. No single projection will work for the globe as a whole. Every projection has some level of distortion in it that will introduce inaccuracy if you try and use flat geometry. That's a result of this man, Carl Friedrich Gauss, famous mathematician. So he was in charge of the survey of Hanover in, I think, 1818. And he became interested in the sort of geometry that comes up when you're having to deal with curved surfaces. And so he came up with this theorem, the Theorema Egregium, means remarkable theorem, in 1827. And the consequence of that is that any flat map is going to have distortion. This is a mathematical fact. The Earth has what's called intrinsic curvature. It has curvature that can't be flattened out without introducing distortion. This type of curvature is now also called Gaussian curvature. So the result is that the geometry on the Earth looks quite different. It's an example of a non-Euclidean geometry. There are no straight lines on a sphere. So instead, the shortest distance between 2 points is not a straight line. It's what's called a great circle or a geodesic. So this is the reason why if you ever look at maps of flight plans, they always look like they're these arcs. So that is actually an example of, that is the shortest distance between San Francisco and London. It makes more sense if you look at it on a globe. So you can see the flat maps always have a distorted view. So when we're doing this geometry on the Earth, the fact that we're dealing with a curved surface means that the math gets lots harder. So for example, distance between 2 points on a flat surface would look like this formula. On a sphere, it looks a little more complicated. And it gets even worse because the Earth is not a sphere. It actually bulges slightly around the equator. It's an ellipsoid. So it looks kind of fat. This is a bit exaggerated, but that's kind of the idea. And these facts make the formulas even worse, if you want to be really accurate. So why does this matter so much? Well, if we think back to that step 2 of index resolution, where we were checking each point to see if it's in the polygon, well, when we need to check if a point is in a polygon, well, the edges of those polygons are actually these great circle arcs. They're these geodesics. And if we want to check if the point is in the polygon, we use what's called a Raycasting algorithm. So the way this works, if we want to check if a point is inside the polygon, well, we draw a line from that point to the North Pole. Let's assume the North Pole is not inside the polygon, and we know that. So draw a line from this point to the North Pole, which is outside of the polygon. And we're going to count how many times we cross the boundary. So maybe it's better to think we're coming from the outside. And so we may go in, out, and so forth. So depending on whether the number of intersections is even or odd, we can determine if the point is inside or outside of the polygon. But in order to do this algorithm, you have to check every single edge to see if it intersects with that geodesic, potentially. We have lots of optimizations in place to rule out sort of easy cases. But in the worst case scenario, every edge of that polygon has to be checked for every point. And so this can get very expensive if you have polygons with very large numbers of vertices. So maybe I'll remark, one of the things you can do if you're interested in tuning the performance of your geospatial queries, if you can get away with approximating with a box, that's best, because boxes are super fast from the index. They don't require that step 2. But if you have to use a polygon, well, maybe do a little bit of thinking about how accurate you really need your results to be. If you have a polygon that represents the state of Texas down to a millimeter of accuracy, well, maybe you can approximate that with a polygon with fewer vertices that only has a meter of accuracy. Something like that, and that can greatly improve the performance of your geospatial queries. All right, so in conclusion, so MarkLogic offers some really great geospatial features, and furthermore, allows you to combine them with all of our other great types of queries and data to make really rich applications. And going back to Jennifer's point, it allows you to unlock your data from silos. Our flexible multi-model approach and our schema agnostic approach allows you to model your data, your geospatial data, in potentially new ways and to integrate it in with the rest of your data. All right. So thank you, and back to Jennifer.
Thanks again for taking the time to go. Okay, we're on now. Thanks again for taking the time to join us today. There's a couple of other sessions that I wanted to point you to in case you're more interested to hear about what neat things people are doing with MarkLogic's geospatial capabilities. There's a session tomorrow where one of our partners, Esri, we're going to be talking about the neat projects that we're working with them on. And EBCON is also a partner that has implemented an interesting application for the Passenger Rail Agency of South Africa. So if you're interested to hear more, recommend you check out these sessions. And thanks again. Feel free to come up and ask any questions you may have. And presentations will be available for download later on this year, as Caroline mentioned. Any questions?
So how does the filtering stuff that you talked about interact with unfiltered searches? We talked a lot about the importance of unfiltered searches. So would you skip that step if I asked for an unfiltered search?
Yes, so if we go back a couple slides here, let me to answer your question.
For the recording, I don't know if you can restate it.
Sure. I'll going back many slides. Let's see. I want my step 1 and step 2. Here we are. Yeah. So the question was, how does this interact with filtering? So, so in fact, all of this that I've been describing here takes place in the index at the time of index resolution. So step 1 and step 2 both occur on the D node in the index. So the search results in terms of the geospatial aspect are completely accurate. Now, where you might need to apply a filter is, for example, if you're if there are particular things that you need to match against. For example, if you had, say, both a JSON property with name coordinates and an element, XML element with name coordinates, and you only wanted to grab the JSON ones using a JSON property query, then if you ran that unfiltered, the index doesn't know whether the entry in the index is from a JSON document or an XML document. So unfiltered would return all of them, but the filter would rule out the XML ones. Similarly, if you're using something like positions, like a near query, then the filter is necessary as well, because the index doesn't know that this particular geospatial data point is located sort of nearby in the document to some other word. And the other case where you'd need a filter is for highlighting. If you wanted highlighting for your documents, then the filter would be necessary. But the geospatial aspect of it is completely accurate without the filter. So if you can get away with it, you can run your, if you have no other reason to run the filter, then you can run your geospatial queries unfiltered.
Great. Do we have time for more questions? Okay. Well, I believe that there are surveys that were passed out. So if you could feel free to please fill out your surveys, provide feedback. And yeah, we'll be up here to answer any of the questions that you may have specifically.
Thank you guys very much.
Thanks for attending.